We still have 1 minute. And I still need to close your chat, and you can only type your answers with me and type your questions with me. Okay. Okay, everyone, it's time. So we will start our calculation skills review session. And the reason we do this calculation skill review session is after last week, we already learned some calculation skills. And also this weekend, and we have a practice paper to let you practice those skills. So today's review session, we just want to use that practice paper to review again what we learned in last week. Okay, and the first part, it should be multiplication skills. And we have several key points. First one is number pairs, right? We should have 2 and 5, 4 and 25, 8 and 125, and we will have 10, 100, 1000. And here we have a special pair, 3 times 37, we will have 111, right? And we have another pair that is 2 can make friends with any 2-digit number ending with 5, right? And the second point, that is finding number pairs. So if we meet a multiplication like this, when we see 25, we want to find 4, but we don't have 4. But we don't have 4 in this multiplication, but we can divide 28 into 4 times 7. So that can provide 4 from 28. And after this, we learn the distributive law. And I think you do well when we have a multiplication in distributive law with addition in brackets. But when you meet a multiplication with distributive law with subtraction in bracket, you always make some mistakes. So in today's review session, we will review this part. Okay, so what is distributive law? That is, we just provide this number, this outside number, to the inside number, right? We use 24 times 5, we use 24 times 9, and we should keep the operation in the bracket. And the second one is we take the numbers apart and then use the distributive law. What that means, okay, so we have 37 times 23. It should have no connections with anything we learned. But if we think 23, we can separate 20 and 3. And the 3 will give 37. And we will have 111 to help us make this calculation easier. And also the same way in rounding. So what that rounding means, when we meet a multiplication like this, 67 times 39. And we know 39 is close to 40. So if we change 39 into 40 minus 1, and we use distributive law, we can make this multiplication much easier, right? And also we will using common factors. So using common factors, that is inverse operation of distributive law, right? If we meet operation like this, we both have 37 in these two multiplications. So that means we can extract 137 and make 17 and 83 in brackets. And also when we add 17 and 83 in brackets first, we will have 100. So that will help us make this multiplication much easier. Okay, so that is the first point, or that is several key points in multiplication skills. And we will use these skills to do these questions. Okay, so you can just work this question with me together, and you can quick type your answer in the chat box. Okay, so for the first question, right? 4 times 8 times 25. Okay, great, great. So when we meet 25, that means we should find 4, right? So we just use 25 times 4 first, and then we time another 8. So that is 800. Okay, so how about the second question? 88 times 125. So how you make this multiplication easier? Maybe someone asked me, we can do 2 types. One is we just separate 88 into 80 at 8. Because we know when we do 125, we need to find 8. So that we do this distributive law. But I think in this question, we should just separate 88 into 8 times 11 times 125, and we just combine 125 and 8, that is 1000, and then we times another 11, that is 11 thousandths, right? So we just use some calculation tricks to help us work out these 2 questions, and then we have these 2 questions. That is obvious distributive law question, and what we do is just remove these brackets, and you can do this question with me. Okay, so that first one is 100 times 25 at 4 times 25. Okay, so what is the first part? That should be quite easy, right? And what is the next part? 100. So that is 2600. And how about the next question? That is distributive law with subtraction inside the bracket. Okay, pay attention. 8 times 1.25. Okay, and we should another one have 0.8 times 125, and we should pay attention. That is subtraction inside the bracket. We should keep this operation. Okay, so what is the first part? That is 10, right? And what is second part? That is 1. And we should have 9. So did that make sense? Okay, we just move to the next question. Okay, for this question, we have some multiplications. And what we need to do is we just need to change this multiplication by our distributive law, right? So the first one, 99 is close to 100, right? So we just need to use 100 minus 1 takes 67. And we just open this, or we just remove this bracket. 100 times 67 minus 1 times 67. Okay, 6,700 take away 67. That is 6,633, right? And also you should make sure I have the right answer. If I make a mistake, you should just tell me, okay? And 201 times 43, because 201 is close to 200. So we just need to change this number into 201 times 43. Okay, and what we have? 200 times 43 at 1 times 43. So we just remove this bracket by our distributive law, and what we have is 8,600 at 43, and that is 8643. So do we have the right answers? I believe most of you will have the right answers. Okay, and next part. Whoa, we have so many questions, and we should use the method finding common numbers. Okay, the first question, which number appear in 2 multiplication? That is 16, right? So we just extract this 16 and put the other numbers in brackets. Okay, that is 67 at 33. What is 16 times 100, and that is 1,600. Okay, the next one. The next one, the same number we should find in both multiplication, that is 5.3, right? So 5.3, and we just put the other numbers in brackets, that is 5.3 times 10, that is 53. Great. And the next one. So for this question, we should pay attention. The 65, we can treat this 65 as 65 times 1. So that makes sense. And we extract 65 and put 99 and 1 in bracket. And that is 65 times 100 and 6,500. Okay, and next one. So when we see a number, we can always treat this number as this number times 1. So that makes this question easier. 11 minus 1, and we just extract 79. So that is 790. Okay, the last question. The last question, when we meet this question, there's no connection with 199 and 99 times 99. But we should know, like, if we meet this, and we should know the question here, it means we should have a method without long multiplication. So what is close to 99 square? So if I just change 199 into 100, that should be quite easy, right? So that means if we can find a 99 in this number, it should be fine. Okay, so can we find 99 in this number? Of course we have. That is 199 at 99 square, right? And for this part, we can just extract 199 and put the other two numbers in the bracket, right? So we just keep writing, and the last part, it should be 99 times 100, and we know this part is 9,900. And we add this 100, we will have 10,000. Okay? So that is 10,000. So for this question, we should have a 99 from 199. Okay, so that is the basic multiplication skills when we do some operations. Okay, and the next part, we should review what we learned in day 2. So in day 2, what we learned, we learned something about product and quotient, right? So we just learned something like when multiplier change, how this product change. And when we also learned something like when dividend or divisor changed, how quotient changed. So for the first multiplication, we know the change of A or the change of B. So that is the change of either multiplier will result the same change of the product, right? So that's, for example, like if A times 10, so how this product change, we just need to times 10, right? And for the division, the change of X, so that means the change of dividend, will result the same change of the result. So what that means, like if I divide by 10 and how the result changed, we should have the same change divided by 10. Okay, and the most important is the change of Y. So that means the change of divisor will result the change of result in opposite direction. So what that means, so if we times 10 on divisor for the quotient, for the result, we should have the opposite direction change. So that means we should divide by 10. Okay, so that is true change on product and quotient. So we just move to this question. 32 times 73, we have 2336. Okay, first, we will write down this equation here. 32 times 73, that is 2336. Okay, how this multiplier change? Times 10, right? Okay, so, and this multiplier, we just keep the same. So that means we just need to times 10 on the product. So that is 360, right? And how this multiplication, we can still write down the original equation and find how they change. Okay, and we just keep the same, right? But for this number, we just divide by 2, and we need to do the same change. So for the product, we just need to divide by 2. Okay, so what is 22,336 divided by 2? That is 1168. Am I right? Okay, I think. So for this question, we just found how multiplier changed to result the product changed. Okay, and for the next question. So, okay, so can you follow my speed? If you can tap yes. And if you think I'm a little quicker, so you can just tell me, okay? Okay, great. Thank you. So I just keep doing these questions. And for this 799, we divide by 7, that is 47. That is the original equation. And we need to use this answer to find the other 2 questions. Okay, first step, we can always write down the original equation. And we should know for this question, I make the mistake, right? Because in this question, we just need to change the divider, right? So we need to have this equation as my original equation. Okay, so how this divider change? We just divide by 10, right? And do you remember how we change our result if divisor changed? We should do the change in opposite direction, right? So if we divide by 10 for the result, we should times 10, right? So that is 170. And the second one, okay? For the second one, we just write down the original equation. Okay, how they change? So for the divider, we just keep the same. Okay, so for the dividend, so how they change? That is times 100, right? And we have the same change on product. So we just times 100 and we will have 1,700. Okay, and we move to the next one. So in this question, that involves some decimals. Okay, so we just need to pay attention. Okay, for the first question, okay, 72 times 1.3, we have 93.6. And we know this number, we just keep the same. Okay, we want to find how this multiplier change. And we can work out this question based on the result changed, right? Based on the change on result. Okay, so how this product changed from 93.6 to 0.936. You can just type like divided by 10 times by 10. You can just tell me how this product changed. How this product changed? We just do what? Divide by what? Divide by 10? Divide by 100? Or or divided by what? Okay, so we just need to work out this part, right? So from 93.6, we change to 0.936. Okay, so that is divided by 100. Okay, great. And how if the product have the change that is divided by 100, and we know this number doesn't change, so that means it should be this number change to result a change on product. So we should have the same change. It means we just divide by 100. Okay, so what is 1.3 divided by 100? That is 0.013. Did that make sense? Okay, so that is the first question. And how about the second question? 70. Oh, sorry, it should be 72, right? I think I make the mistake, right? So here we just divide by 2, right? Okay, sorry. So for this part, I just divide by 10, and how this 1.3 change to combine these two change to make divide by 100 on product. Okay, so I think I need to pay attention about this part. And for this question, I think one multiplier divided by 10 and the other multiplier divided by 10, they combine these two change can make the product divided by 100. Okay, so that means this part, it should be 0.13. Okay, did that make sense? If you understand, tap yes. Okay, and I just correct my mistake. Okay, thanks for understanding, and I will move to the next question. And I will write down the original multiplication, that is 72 times 1.3, that is 93.6. Okay, how this 72 change to 114.4? Okay, that should be a little difficult, but I can just tell you that is divided by 5. Okay, and how this 1.3 change to 13, that is times 10. Okay, for this question, can you just tell me how this product change? One multiplier divided by 5 and the other one times 10. Okay, just tell me how this product changed. We should combine these two change, right? So just tell me how this product changed. You can type your answer in the chat box. One is divided by 5, the other one is times 10. So how this product changed? Okay, so think about 1 is divided by 5, 1 is times 10. How this product changed? Okay, so that should be times 2. If that makes sense? 1 multiplier times 10. Okay, so if I change this part, okay, so if from this multiplier, this number from 1.3 to 13, we just times 10, right? So this change will result the same change. Okay, so I finish this part. Okay, for this part, 72 to 14.4, that is divided by 5. Okay, we should keep the same change, right? And if we combine these two change, that is times 2. Okay, and what is 93.6 times 2? That is 180, 70, 100. 87.2. If that makes sense? Are we okay for that? If okay, I will move to the next question. Okay for that? You can just tap yes or no, okay? Okay, great. I will move to the next part. 117 times 339, that is 39,663, right? So that is a huge number. And how we have this part? Whoa. How we have this part? That is very interesting question. How we have this part? Okay, I will first write down my original multiplication. That is, okay, how this 117 changed to 39, and how this 339 changed to 33.9. Okay, so from 117 to 39, that is divided by 3. So I just first divide by 3, and from 339 change to 33.9, that is divided by 10, right? So that is divided by 10. Okay, so that should be our result. And what is the result? Okay, with first step, we just do the division, that is 13221, and we divide by 10, that should be 1322.1. Okay, great. And how about the next part? Okay, for the next part, we should keep our original multiplication to help us find the answer. Okay. And first, we observe our result, our product. How this product change? We just divide by 10, right? Okay. And for this number, from 339 change to 1.13, how this number changed, that is divided by 300. Okay, so this question, how this 117 change to make the final product have the change as dividing by 10. You can type your answer in the chat box, right? How this 117 change to make the result change by dividing by 10. Okay, we just divide by 300 by this multiplier, and but finally our product only divide by 10. Okay, so how this number change, that is time 30. Did that make sense? Okay, did that make sense? So if you cannot directly find the change, so the result should be 3,510, right? Okay, so I will show you another way to find the result. So when we do the multiplication, that means we always do, when we meet a multiplication, it means if we do inverse operation, that should be the division, right? So if I give you this division, we just need to find this result, right? And from this original multiplication, how we find this part, okay? From this dividend, we just divided by 10, right? And how this change, that is divided by 300. Okay, and we do know if we want to find the result for this part, okay? I just first write down this number, okay, from the change on dividends, that is divided by 10, and we need to do the same change, that is divided by 10. But when we meet some change on divisor, we should do the opposite change, right? So we divide by 300, we just need to times 300, right? And finally, that is 117 times 30, and we can still find the answer, right? So I think maybe this method can help you understand this question well, right? So you can just keep this method in your mind. When we find the multiplication, we can still change this multiplication into division to help us find the answer. Okay. And we just move to the next part. So that is something about new operation. And if we want to do some new operation, we only need to remember, we just put the numbers in place according to the rules. And we should know the BIDMAS rule and don't swipe the order of calculation, right? And for the first question, we have a hat here, and to define a brand new operation. So we have some examples. One hat, that means one, that is the number itself. So that means this number times 2 at this number itself. So we can find the same rule by the second one. So if we just write down this new operation, that is double this number and add this number itself. Okay, so if we have this part, true hat, so for the first one, we just need to work the number in bracket, right? That has the priority, right? So true hat, that is 2 times 2, add this number, that is 6. And for this part, 100 times 2, add this number, that is 300, right? And then we just need to add 6 and 300. That is 306. If that makes sense? And I found most of you tap 206. Am I right? I think I'm right. 100 hat, that is, we just double this number and add this number itself, right? So for this part, 100 hat, we double this number and add this number itself, that is 300. And the first part, we just do 2 times 2, add 2, and we just have 6. Oh, sorry. I think I made the mistake, right? We just add 1. Sorry for that. Okay, I will change this part. Okay, so the first is double this number and add 1, that is 5, and 100 hat. We still add another one, that is 201, and 5 add 201, that is 206. You're right, I'm wrong, okay? Sorry for that. And I will move to the next question. Okay, for this question, I know that is a little difficult because that involves a linear equation. And we have a new operation like this. So if we just do the simulation on this operation, that should be 9 at x divided by 5, that is 40. If that makes sense? Okay, and that is what we need to solve this linear equation. So I first step we need to do is we should keep the equation balanced. So we will do the same operation, right? So if we times 5 on one side, we just need to time another 5 on the other side, okay? So that is 9 and x. And we divide by 5 times 5, we just eliminate these two 5, and we have 200. And x is 191, okay? So great, and we will move to the next part. Okay, for the next part, that is sum of an arithmetic sequence. And we have a general method that is sum is first term and last term times number of terms divided by 2. Do you remember how we have this method? We just have one arithmetic sequence like 1, 3, 5, 7. And how we have this method is we just list this number in an inverse order, right? So that is 7, 5, 3, 1, right? And if we just take two numbers in one column, we will always have the same sum in each column. So that is the reason we have this general method. Okay, and we have another special method that is middle method. That is the sum of one arithmetic sequence, that is middle number times number of terms. And the reason we have this method is in this special arithmetic sequence, the middle number is always the average number of this arithmetic sequence. So that is the reason we can have this method. And we should have some special limitation is when you want to use this method. This arithmetic sequence has the number of terms that is an odd number, okay? And we have these two questions to practice these two methods. 1, 3, 5, 7, and 39. And this dotted points means we have other numbers following this pattern, okay? So the first term 1, the last term 39. Okay, how many terms in this arithmetic sequence? Is this 39 or other numbers? 39 terms or other number of terms? You can type your answer. That is 39 terms or other number of terms. Am I right? 39 or other number of terms? Okay, great. So we should have another number that is the number of terms in this arithmetic sequence. We should have 20. Okay, how we have this 20? So we observe this arithmetic sequence that is from 1 to 39. That is all numbers, right? So if I think from 1 to 40, how many odd numbers? How many even numbers? So that should be half and half, right? So that is 20 odd numbers. And we divide by 2, so that is 40 times 20 divided by 2, and we have 400, right? We should pay attention. We need to divide by 2 at last. So that is 400, right? And for the next question, we have 1, 2, 3, 4, 5, 7. Sorry, 4, 5, 6, 7. 7 terms, right? So that means this arithmetic sequence has the number of terms that is odd. We can use middle method. So what is middle method? We should first find the middle number in this arithmetic sequence, right? So which number is the middle number? 36. That is the fourth term. So 36 times 7. Great. That is 252. Great, all of you. And we can move to the next part. And in this question, that is how we work out some multiplication puzzles. And for this type of question, we have some tricky methods. The first one is we always analyze these multiplication puzzles from the last digit. Okay, so how does that help us find the result of this question? Okay, from the last digit, 4 times what? We can have a result ending with 8. How many options? We only have 2, right? 4 times 2, we have 8. 4 times 7, we have 28. So if we put 2 here, can we use a 2-digit number times 2? We have a 3-digit number starting with 4. Okay, you should think this question. Can we have a 2-digit number times 2? We have a 3-digit number starting with 4. Obviously not. So that means we should have 7 as another multiplier, right? Okay, so that 4 times 7, we have 28. So that means we need to carry 2 on the next digit. Okay, and how about this digit? This digit times 7, we should have a result that is starting with 4. We have 2 options, right? 7 times 6, that is 42. 7 times 7, that is 49. But we need to pay attention. We should carry 2 on the next digit. So if we have 7 times 7, 49, we add 2, that is 51, right? So we cannot use 7 times 7. So we should have 6 here. And if we confirm that it is 64 times 7, the result is 448. Congratulations, and we move to the next question. Okay, for this question, we can still analyze this question from the last digit. So 3 times which number will have a result ending with 1? We only have one option, okay? That is 7. 3 times 7, we have a result ending with 1. And we should carry 2 on the next digit. And if we carry 2 on the next digit, we have a result ending with 6. So that means the result at 2, we have 6. That means this number times 7 will have a result ending with 4. And we add 2 on this, we will have 6, right? So which number times 7 have the result ending with 4? That is, which one? 1 times 7, 2 times 7, right? 2 times 7. We have 14, add 2, that is 6. 16, so we just add 1 here. Okay, so 7 times 7, 49, we add this carry on 1, we have 50, right? So that's a 0, and we can just keep finding the first digit here. So we just add 5 here, and we know we're starting with 2. So that is 3 times 7, add 5, that is 26. Okay, and the A is 0. Great. And we should talking about something about magic square. So in magic square, we have several key points. First one is the sum of numbers in each row, column, and diagonal is called a magic number, right? So if we have a magic square like this, so that means the sum of these lines or these columns or these diagonals, that will be the same, and we call magic number. And the sum of all the numbers in magic square divided by 3, that is magic number. So that means all numbers in this diagram, we add them together, we divide by 3, that should be the sum of one line, that is magic number. And also magic number divided by 3, that is center number. Okay, we have a magic square here, and this one is center number. And this number times 3, we will have magic number. And magic number divided by 3, we will have center number. Okay, so based on this part, we will have the next conclusion, that is center number equals to sum of two numbers in the diagonal line divided by 2. So what that means, so no matter diagonal line or any line has center number if we do know the other two numbers. For example, if we know this number and this number, we should know the center number is half of their sum. If that makes sense? Because this line is the sum. This line is a magic number, is the same sum of each line. Okay, and we should know the magic number is center number times 3, right? So if we replace this magic number as 3 center number, if we have this magic number as 3 center number, that is center number at the other two numbers, right? Center number and other two numbers. So if we eliminate one center number from both sides, it means we should have 2 center number. That is other two numbers in this line with center number. Okay, so we should know center number is the half. Center number is the half of the other two numbers, the sum of other two numbers. If that makes sense? If it makes sense, or if that is okay for you, we will move to the question. Okay, so in this magic square, we don't use previous knowledge. We only need to know what is magic square. That is the sum of the numbers in each row, column, and diagonal is the same, right? So focus on this row, focus on this column. These two lines sharing the same square, right? And we do know this column and this row will have the same sum and sharing the same square. So that means 7 at 5, that is 8 at this unknown value, right? So what is this part? That is 4, right? So that is option D. And the next question, if we meet this magic square and we have the center number already, that means we already know the magic square. Sorry, we already know the magic number. So what is the magic number? That is the sum of each line, right? So what is the magic number? 6 times 3, we have 18. So if we know each line will have the sum at 18, okay, we want to find the value of A. So if we put A in this row, what is the value of A? 18, take away 9, take away 2, we have 7, right? So that is 7. So for this question, we have this center number, right? We need to use this center number to find the sum of each line, and then within the sum of each line, we should find the value of A. Okay, and we just move to the last key point. That is divisibility rule. We should have 3 rules by ending digits. 2 and 5, we only focus on the last digit. If the last digit is the multiple of 2 and 5, this number should be divisible by 2 and 5. If the last 2 digits is the multiple of 4 and 25, this whole number can be divisible by 4 and 25. And if the last 3 digits. That is the multiple of 8 or 125. This number can be divisible by 8 or 125. And we have another type of divisibility rule, that is, we should focus on the sum of these two numbers, 3 and 9, right? And if the sum of its digits is divisible by 3 and 9, that should be this whole number should be divisible by 3 and 9. Okay? And which of the following is divisible by 3? Okay, we add them together: 8, 13, 6, and 10. Which one has the multiple of 3? Option C, right? And how about this question? 4-digit number 231A, where A is a digit, is divisible by 4, the smallest possible value of A. Okay? So for this question, we have another question that is smallest possible value. And we do know when we find a number is divisible by 4, we only focus on last 2 digits. So that means we only focus on 1A. If 1A is the multiple of 4, this number should be the multiple of 4, right? And do we have any other 2-digit number starting with 1 that is the multiple of 4? Of course, we have. That is 12, right? 16. Do we have other options? We don't have other options. And for 12 and 16, and for the value of A, so that means 2 or 6. So which one is the smallest possible value? Obviously, that is true. So the answer for this question is true. And that is the last question for our practice paper. And today's review session, it is over. That's it. So hope you will learn or you will review this knowledge, and you can just practice this paper again to prepare the final competition. So hope all of you will have a great result in the final competition in this Thursday, 7 p.m. So bye.